Salman. Thank you. My name is Salman. I am president of ASHRAE IIT student chapter. Welcome everybody in person. Thank you very much for joining us in person or online. Today we are going to host an energy modeling workshop using RETScreen. I also want to thank you very much from Bowman from IBPSA-USA and also NRCan for collaborating and also for supporting this. Our first speaker is Hardik. Hardik is the Energy and Decarbonization Manager at Bowman Consulting, where he leads efforts in energy efficiency and commissioning and retro commissioning. I want to welcome you, and please feel free to start.
Thank you for the warm welcome. Let me share my screen. Thanks everyone for joining the webinar as well as in-person training on benchmarking to so the topic is benchmarking to building performance standards, compliance, planning using RETScreen. So the agenda for today's training will be, I will be providing an overview about the RETScreen, what are the applications where the software is being used, what are some of the limitations, providing an overview about what is building performance standards and what is the process involved in it. We will be diving through one of the case study and answering any question and answer at the end of the session. Starting with the overview of RETScreen. So RETScreen, as the name stands, is Renewable Energy Technology Screening. So this is one of the software that is being developed by, that is widely used in clean energy management software for working on projects related to energy efficiency, renewable technology, cogeneration facility, and doing ongoing energy performance analysis. So this software helps to quickly gauge the facility's energy performance, how it is currently performing, that is using benchmarking, doing a feasibility analysis, like suppose if you're working on energy efficiency projects, so you can do a feasibility analysis, and later on evaluate the energy and cost savings associated with what is the reduction in the greenhouse gas emissions, and doing a financial check as well. This software also helps to determine the energy production and savings potential at any potential location across the world. And it also helps to verify the performance of implemented projects and to find opportunities for further energy improvements. It also helps to manage a large portfolio of clients, like suppose if you are working for 5 to 10 properties or more than that. So this software also helps to work for a single building as well as a portfolio of clients in one go itself.
Sorry to interrupt. There's a comment in the chat that says the screen that is being shared is not correct. We still see the PPT.
Okay. Is this good?
No. We still see the presentation.
I think we just. Sorry.
Yes.
Perfect.
Now.
Okay. Again, this software is available in 36 languages that covers. Oh, yeah, it's okay. On that, this is coming proper. Yeah, okay. I think. So this software is available in 36 languages that covers almost 2/3 of the world population. So this software is currently developed by multiple developers and partners across the globe. That includes Natural Resources Canada, Renewable Energy and Energy Efficiency Partnership, Independent Electricity System Operator, United Nations Environmental Program, NASA, as well as Global Environmental Facility. So understanding the application of the software, like where can you use this software? So there are multiple features that are available in this software. It all starts with virtual energy analyzer. Suppose if you're working for a client where you don't have any information and the client is asking to understand what is the energy saving potential for their property. So you can directly use the energy analyzer tool, which uses the typical consumption for a particular building and using corresponding like archetype and estimates what is the savings potential for a particular measure. Benchmarking analysis, again, this is another feature within RETScreen that helps to model the building as compared to other similar reference building and to understand how is it performing compared to other buildings of similar type and location. Feasibility analysis is again, this is more of a modeling a clean energy project, including analysis related to energy efficiency projects, understanding what is the cost for implementing the measures, what is the reduction in the greenhouse gas emission, and doing a risk analysis. Then we have the performance analysis. That is a place where, suppose if you have already implemented the measure and you want to verify what is the reduction in your annual electric or natural gas usage. So this is a tool that you can use. And portfolio analysis, as I said, like if you are working across multiple properties, you can do all the analysis in one go. So these are the sectors where RETScreen is widely used across the globe. It includes the power plants, if you have power heating, cooling generation, battery storage, that includes thermal, electrical storage, industrial or agricultural facilities, commercial buildings, residential buildings, and transportation. So these are the wide applications for the software. For any software, there are a few limitations. Again, RETScreen has some of the limitations that we should be considering when we are working and deciding which is the best software when you're working on any project. First, RETScreen doesn't include latent heat in cooling load calculation. So usually there are two types of loads, sensible and latent. So RETScreen doesn't use that for its calculations. Simultaneous heating cooling is not considered while doing energy saving calculations. But again, the user needs to specify what is the changeover temperature. That is the temperature at which these systems transitions from heating to cooling or cooling to heating. Thermal mass of the building can't be specified in RETScreen. Occupant sensible and latent heat gains cannot be specified directly in RETScreen, but it can be included as a bogus electric load. That will something we will be diving during our case study. We can't specify when during the day the building is occupied. Like I cannot specify my building is operating or my HVAC system is operating from 6 p.m. to 6 p.m. But I can certainly mention my systems are operating for 12 hours per day. Right? So it doesn't work based on the actual time schedule, but you can certainly mention the operating hours. The power factor correction is not addressed in RETScreen. It does not include any reduction in the peak demand. So these are some of the limitations for RETScreen. So first, starting with building performance standards. So what is that? So across the United States, there are multiple states, cities, and jurisdictions who have come up with building performance standards, which means it helps to decide how so the jurisdiction has placed a law, like in order for you to comply with the requirement, you need to maintain this much amount of energy or emission for your property. So right now, so these are the locations where the building performance status has already passed, or it is either based on emissions. It can either be based on the energy consumption, or it can be a combination of both. There are quite a few cities and states that are still under consideration, whether they should be working with the BEPS requirement or not for their location. But again, the BEPS requires, like suppose if there is a facility in Washington, DC. So if you don't comply with BEPS, which means a particular building needs to meet a certain energy requirement, energy consumption requirement in terms of kBTU per square feet. If you don't meet that requirement, by certain year, you might be penalized for using extra energy. Right? So each jurisdiction have a different requirement. Some are penalizing them for wasting the energy. Some are asking them to benchmark their property and ensuring they're meeting the requirements. So each jurisdictions have a different requirement. So to get started with, so there is a lot of, there are quite a few clients across the nation who are very much worried. Like right now, their property is not complying with BEPS. So what they do is they directly start with the retrofits for multiple projects. That includes like optimizing the control system or reducing the lighting load, that is like lighting retrofits, or doing the building envelope fixing, like sealing the envelopes. It could be fixing or doing retrofits for air and water systems distribution. That includes a chilled water, hot water system, and including the heating and cooling plant retrofits. So this is how the clients are like, I need to meet the BEPS requirement. Let's do the retrofit. But the first step that we need to understand is how is the building currently performing, right? There could be a project where it is just 5% off from the BEPS requirement, and there could be one that is 50% off. So if you do the same retrofit for both of the buildings, the amount of money that you are spending for a project that requires only 5% retrofit will be much higher, right? So that is a place, the first thing that we need to do is to benchmark the property to understand how is the building currently performing against others. How far is it from the BEPS requirement, right? And how much extra efforts or how much cost resources they need to allocate in order to comply with the BEPS requirement, right? So that is a place we need to first benchmark the property. Now let's understand what is benchmarking. Benchmarking is, since most of you have been in universities, so whenever you get a grade, it gets normalized. Like how is your performance against the others, right? So it's very similar to that. It is done for buildings to understand how is your particular building performing against other buildings in the same climate zone, in the same building. Sorry about the technical glitch. Can everyone hear me now? Need to some. No. No, okay, can everyone hear me? Good. Okay, and screen is good. Okay. Sorry about the technical glitch. But again, so we stopped was Energy Star Portfolio Manager. So before we do start working on any energy efficiency project, we need to first understand how is a building currently performing. So for that is known as benchmarking, where you verify the performance of your building against the other in the same climate zone and the same building type, right? So Energy Star developed their own tool that is known as Energy Star Portfolio Manager that gathers all the utility information about a particular building, and then it does a normalized weatherization and accordingly determines what is the performance of your building against the other. So they rate your building on the scale of 0 to 100. If your building is having a score of 75 and above, your building is eligible to receive an Energy Star certification. Having a score means your building is performing. Let's suppose a score of 62, which means your building is performing 62% better than the other. right? So that is what we do as part of the benchmarking. So once you benchmark the property, we understand like right now the building is not compliant, right? So we get started working on energy efficiency. So for working on energy efficiency project, assuming we are doing an energy audit for a particular building, right? So we go into the facility, assuming you are coming in this room right now, right? So you enter the room, you understand what are the heating and cooling loads, right? So you first you understand what are the sources of fuel, right? So you have electricity for getting all the lighting and air conditioning. If you have heating and natural gas, so those are the two fuel types that you have, right? Next, we understand what are the equipments in this, right? We have the lighting, we have the air conditioning, we have the plug loads through computers, right? So those are the different equipments that we have that contributes to that. And end users is again, like what are the end users that includes all the plug loads and stuff. Once you develop a baseline case, so baseline over here refers to you are creating a virtual model about the property that you are doing an audit for, right? So once you develop a baseline case, next step in the process is to calibrate the model, right? Suppose if this space is having an energy consumption of 100,000 kilowatt hours, you need to ensure the virtual model that you are preparing is plus minus 10% within the actual consumption, right? That is a place where we do the calibration. So when we prepare a virtual model, we always make quite a few assumptions depending upon the information that is not available. It includes the set points, like the heating, cooling set points in the space. What is the building envelope construction out here? What are the operating hours for the lights? Like how is the building occupied? So there are multiple things where we might have to make an assumption. And accordingly, we calibrate our model to ensure it is very close to the actual consumption based on the utility bills. So once you develop the virtual model, next step in the process is to do like work on energy efficiency, where you come up with list of energy saving measures for the client. So the first step is to, whenever we work on an energy efficiency project, first step is to reduce the consumption. We shouldn't always start with suggesting like to install solar PV panels. Ideally, that should be the last step, right? First is always to minimize the consumption. What are the opportunities where you can reduce? It could be through scheduling, right? It could be doing lighting upgrades, or it could be changing the set points. So these are like minimizing the usage. Next step is maximizing efficiency. That could be like equipment replacement altogether. And the last step in the process is optimizing the supply. That could be how you're getting the electricity for your property. Is it through solar PV panels or you are buying renewable energy credits? So there are multiple factors. So this will be the approach that we will be considering for our today's case study. But once you are done with the energy efficiency, now assume the recommendation that you gave to the client has implemented all those measures as part of energy audit. So the next step in the process is for us to verify whether there is an actual reduction in the energy consumption or not. That is through performance verification. So we have the baseline consumption, the one in blue, right? The one in red is a duration when the client implemented the measures that we recommended. And the one in the green versus the blue, that is a difference that we see, like the reduction in the energy consumption. The one in green is more of a predicted energy usage, had it been they had not implemented the measure. The one in blue is the actual consumption. The difference of that is the energy saving. So all this, now just imagine if you are working on a project, you are using a separate tool for benchmarking, you're using a separate tool for energy efficiency, working on energy audit, then you're using a separate tool for performance verification. The amount of coordination that needs to happen between the data transfer within the team, gathering the data and ensuring it is meeting the requirement or not, it's very tedious, right? So RETScreen is one of the software that helps to solve all this issue. Right from benchmarking until performance verification, you can do everything in one software. So that is something that we will be diving today to see how RETScreen can be helpful. So as part of the case study, so we are considering a portfolio of client in Washington, DC. So Washington, DC already has building performance standards requirement, right? So we are looking at 4 residential properties in Washington, DC. Everyone having a different square footage, right? And year of construction. So right now we are starting, I will be sharing my screen to understand how the buildings are currently performed in. So the first step for us to understand is benchmarking. How is the building currently performing? So we are assuming the client has already benchmarked all of the 4 properties in Energy Star Portfolio Manager. So the first step for us is to import the data from Energy Star. Oops, sorry. I think it's not. Sorry about that. Sharing this. I think we might have to change this. Sorry about that. There was 2 technical issues out here. Are you able to see this?
Yeah, that's good.
Let's see. So oh, get to 3 screen. Okay, got it. Oh. This is good. Okay. There are a lot of technical issues. Okay, so we stopped at benchmarking. So right now there are 4 properties in Washington DC who needs to meet the BEPS requirement. So the first step that a client did was to benchmark their properties in Energy Star Portfolio Manager. So that is what we will be looking at today. So what are the steps where you, so first step is for us to import the data from Energy Star Portfolio Manager to RETScreen. So the way it is done is you go into, for people who already have Energy Star Portfolio Manager access, so you go into the software dev, so you go into the account settings, software development, and you need to enable your web API services, and just mark it as yes out here. So once you mark it as yes, Energy Star will take an approximately like a couple of days to approve getting an API access. But once you get an API access, so the thing that you need to do is you need to go into the file tab out here, connect with your RETScreen. So you will be having a username and password and creating a new portfolio, and you can directly import all the files that you have in your Energy Star Portfolio Manager account into RETScreen. So again, depending upon the number of properties, it will take a lot of time. So right now, for considering the time constraint, we have already imported 4 properties into RETScreen. So the thing that we are currently looking, so there are 4 residential properties that needs to comply with BEPS. So we have imported all the information that includes the area where the building is located, what is the electricity, natural gas consumption for the past quite a few years. So the first step, we need to understand how is a building performing, whether it is meeting the BEPS requirement or not. So we go into the dashboard tab, we plot a benchmarking graph to understand what are the properties that are complying. So I will just give a name of benchmarking. I'm using the unit convention of kBTU per square feet, and I will be plotting a graph. So these are the 4 properties that I imported through RETScreen. So the one in green is the actual performance, that is a baseline consumption. The one in green is what is a target that I need to set. Like if I want to reduce a particular consumption by 25%, so that is a target that we are setting. So now let's understand how many properties are currently complying with BEPS. So I'm assuming like for residential property in Washington, DC, they need to have at least 37 kBTU per square feet in order to meet the BEPS, in order to comply with BEPS, right? So that is the graph that I plotted. So all the plots that are above this graph, which means they are not complying with BEPS right now. If you see any data point that is below this, which means it is complying with the BEPS requirement. So right now for our case study, none of the 4 properties are complying with BEPS. So now we had this conversation, with the client. And so the next step that we suggest to the client is to conduct an energy audit, right? So for that, what we do is we go back to the portfolio. Assume we are doing an energy audit for one of the residential property. In this case, assuming we are doing for building 4. So this is a place where we open one of the property and develop the baseline model, a virtual model of RETScreen for that property. And we directly open file. Okay, so this is how the dashboard for RETScreen looks like. So in the file, you have all the features that you can use. So this is the overall dashboard that we have for RETScreen. So this is a place that the file tab where you can select what type of projects you want to work on. So whenever we get started with any energy efficiency project, we need to first define the location, right? So since our project is currently based in Washington, DC, so that is a location that I have set. One thing to always remember while working in RETScreen, since this software is developed by Canadian government, it will be using metric system. So the first step, if you are working for any projects in United States, you need to go into the settings and ensure your the unit system is changed to imperial. Another thing, since it is a Canadian software, the dollar amount that is mentioned out here, it is a Canadian dollar. So you need to ensure you're updating your currency to United States. Depending upon what your project location is, you need to update that accordingly out here. So once you are done, we update the location. Accordingly, it imports all the weather files for that particular location. Next step is for us to define what type of facility it is, right? So for us, it is a residential property. It is a multifamily building, right? The location of the property, we specify the square footage, and we know the current baseline case. So this baseline case is something that we are getting from Energy Star Portfolio Manager. What is the building currently consuming in terms of energy usage? So accordingly, we understand how is a building performing. Benchmarking is something what the performance, the BEPS requires in order to comply with. So we are setting a target a little bit above the compliance requirement so that it is meeting the BEPS. So once you benchmark the property, next step in the process is for us to create a virtual model. So first step in the process is for us to determine what are the fuel sources. So we have electricity and natural gas. We have the fuel rate, like how much you are paying per therm or per kilowatt hour basis. So that is something that you can define out here. Next step in the process is to define the schedule. Like what are the set points at which your equipments are operating? For how long are they operating on a daily basis, right? And what is a changeover temperature? Changeover is at what temperature does it transition from heating to cooling or cooling to heating? So once you define those, next step in the process for us is to define what are the equipments in the building. So for the audit that we have done, so there is one natural gas boiler that is having an efficiency of 65%. So that is, so you go into the heating tab, you define all what, depending upon what heating equipment you have on site, that is something that you can define out here. There could be heat pumps, there could be water heater, there could be district heating system as well. So that is something that you can define out here. Next, there is a water heater in the building that is having a seasonal efficiency of 70%. Process heat that is having a seasonal efficiency of 100%. You can select the source of fuel as well. If it is electric boiler, you can change the source to electricity of use and accordingly define what is the fuel source. Next, we go into the cooling load. So in this particular building, they have a chiller that they are using. So that is something that we are considering out here as a compressor. So you go into the cooling and select what type of equipment you have. It could be a district cooling system, compressor, or absorption chiller. Accordingly, you can define the system out here. Once I have defined the equipment, next step in my process is to determine what are the end uses. Where is my energy going? First step that we define is the building envelope. Right? It includes the roof, the walls, windows, the floors. So that is something that we define in building envelope. So the way we do is go into the energy tab, go into the building envelope, and this is, so I've already preloaded all the information out here for our case study. But first step is to determine what is the orientation of the building. What is the wall area, window area, what is the R value, U value for those building envelope conditions. What is the door area, skylight, if it is there, what is a wall below grade, what is infiltration rate out here. And accordingly, you can determine, you can define the building envelope for your property. Next step in the process is to define what are the lighting systems, right? So that is something out here. So there are stairwell lights. That is something that we have defined out here. So depending upon what type of lamp you have, you can select it from the drop down. Quantity of lamps, the number of fixtures, the operating hours, and whether it is contributing to the heating cooling load or not. Most of the lighting that is coming out here indirectly affects the heating cooling load. So that is something that you can define whether the end uses that you are defining, is it contributing it back to the heating cooling load or not. Right? Something similar is something that is there for basement, CFL. So these are all the baseline information that we have. Next, looking into the plug loads, like what are the kitchen appliances that might be there. So that is something that we have defined. So you go into the energy tab, go into the electrical equipment, and that is a place where you can define all your kitchen appliances that you could have for your property. So that is something that we have defined out here. Next step in the process, they have domestic hot water system that comes in the bathroom. So that is what we have defined out here. So since it is a residential building, we have selected the load type as apartment. We know the number of residential apartments, what is the occupancy rate, and accordingly, RETScreen helps to determine an estimated hot water usage for that particular project. And accordingly, if you have your actual usage from the energy audit, that is something you can define. You have the hot water supply temperature, the operating hours, and accordingly, it will estimate the heating usage through the domestic hot water. Next, there will be motors for circulating the water through the pumps. So that is something you can define, you go into the motors, and that is something, in this case, it is an elevator motor. So there will be elevators, so that is something that we have defined the energy usage for those. There is process electricity, there will be laundry, like washers and dryers in the building. So that is something we are estimating the energy usage out here. There could be a few apartments that is having electric ovens, so that is contributing to the electrical usage. And there could be gas, like natural gas cooktop as well. So that is sort of a different way that you can define it out here. So once you prepare the baseline, right, the next step for us is to understand, I have prepared a virtual model. How close is it to the actual consumption? Right? That is something that I need to define. So in this case, I will just show a quick demo of some of the lighting measure. Assuming like I have done an energy audit for for the same building. So I am having a compact fluorescent plug-in lamps, and it is having a 13 watt of electrical load. It is having a miscellaneous losses. I'm assuming there is no losses through it. The number of fixtures that we have is 7. It is operating for 24/7. And the quantity, like the number of units for which I have determined is 5. And it is currently contributing 100% to my heating cooling load. So in my proposed case, if I want to directly transfer all my information from baseline to proposed, I directly select it out here. It transfers all my information out here. Something similar, if I want to provide information about the pumps. Okay, so I have a recirculation pump that I can define out here. It is having a standard efficiency and it is having a HP rating of 0.0833. Or if you have like a kilowatt rating, that is something that you can define out here directly. It is operating at having a load factor of 75% and having an efficiency of 80%. It is operating at constant load for 24/7, and there is only one recirculation pump in the building. So this is something that I'm defining as a baseline case for my property. If you come across a project where you don't have the information, like what should I consider as my load factor? I don't know what is the efficiency of the pump. So RETScreen has a very good feature where if you select efficiency out here, it will provide you with a typical range that you could potentially consider for your project. So that is something that can be defined out here depending upon the system that you have. Another feature that RETScreen has is interactive effects. Is something that Hiten will be covering during his presentation. But once you develop the virtual model in RETScreen, the next step for us is to understand how close is this energy consumption from the actual energy consumption. So we go into the comparison tab, and this is a place where we mention the annual usage for the property, right? So we determined, like back in 2022, that is a baseline case for us. The building had almost 31,000 tons of natural gas consumption and 270,000 kilowatt hours of electricity consumption. So the model that we have prepared is almost within plus minus 10% of the actual usage. So this is something that helps us to be confident, like the model that I prepared is very much in line with the actual usage in the building. If you come across a situation where the model is more than plus minus 10%, that is a place where you need to do the calibration. And calibration can be, the first step is to ensure any place where you have made an assumption, is something that you can vary and ensuring that it is compliant, it is within plus minus 10% of the variance. So this is the place where we have completed the baseline model and created a virtual model. Now the next step in the process is now we have recommended few energy saving measures to the client, right? So there will be 2 to 3 measures that Ethan will be showing in RETScreen, like how do we estimate the energy savings using RETScreen. Should we take a?
Yeah, we had a few breaks.
Yeah, we can take a 5 to 10 minutes break.
Okay. I thought we had a few breaks.
Oh, sorry. Okay. I think we can continue. Yeah, I think we already. Thank you very much on time.
Hey guys, good afternoon. My name is Hiten Chajir. I'm an energy and decarbonization project manager at Bowman Consulting. I will continue the rest of the presentation and the energy model today. Apologize for the glitches, but I think we've taken care of that now. I noticed there were a couple of raised hands in the chat. Before I start with my presentation, do you guys have any quick questions that you want to ask or? Yes, go ahead. So we have a question from the room.
Okay, so when I saw you conveyed the heating and cooling, so because as an architecture student, we also do the same thing in one class. But so the problem is, what if you're facing an old building, then you don't know the wall material, because that's quite a customization. It couldn't be found like the R value often couldn't be found in the design manual or what. So how do you do that? How do you know the R value or what?
That's a great question. So the question is, what if you're modeling a building and you don't know the R value of the walls, and you don't probably have drawings that could give you the accurate information?
Yes.
To answer that question, let me share my screen again. Can you guys see my screen? People who are on the webinar? You can see my screen. Wonderful. So to answer your question, RETScreen has a database for different materials and different R values. As long as you know what the layers of the wall are, or even if you can have a good guesstimate of what the wall comprises of, you can go to the exterior wall. This is a wall property, and you'll see you can add layers for the wall, and it'll give you the effective R value when you put in the thickness of that particular material. So in this case, we know that it's a brick wall with concrete and gypsum board. We know the thickness of the wall, or we've made certain assumptions, and it will give you the R or the U value for that wall. And it will combine, you can also add, it also includes air barriers, you can add penetrations, it will do the whole thing for you.
Okay, so that's all. But is that like a consumption data, like you already talked about the some bridge or something?
Is there a database where you can see all those values? Is that what your question is.
I mean, but they also like a girdle inside the wall. Is that data out here considered about like the summer bridge? The summer bridge. The summer bridge.
The thermal bridging of the wall.
Yes.
So it does,
Oh yeah.
and you can add a frame to it,
Uh-huh.
and you can add a frame to these layers, and you can estimate the thermal bridging, if it's thermal bridging or not.
Oh, okay.
But there are workarounds. There's no direct thermal bridging option in the wall properties. You'll have to go through different workarounds to get that.
Oh, okay.
All right. Unless there are any other questions, I'll start with the measures. So what we saw, or what Hardik presented, was a baseline model, meaning how much energy the building is using currently, or a prediction of how much energy the building is using. We are going to simply implement three measures. The building owner planned to implement three measures in the period of 2023, in the calendar year 2023. One was upgrading the existing boilers to condensing boilers. They identified that their boilers are really old and they want to upgrade it to a condensing boiler. So we go to the boilers, which is the equipment. There are two ways you can go about it. You see this checkbox where it says heating equipment. You can check that. And RETScreen has a database of different boilers. You can select the system. In our case, it's going to be a boiler. You can select the manufacturer. You can select the model, and it'll show up the capacity and it'll paste the data for the proposed case. In our case, we're not going to do that because we know what the efficiency for a condensing boilers is. We have the technical sheet, we have the spec sheet. We know that the efficiency is 95% for the condensing boiler. So I'm simply going to change my efficiency in the proposed case to 95%. Now that I've upgraded the boiler, the next measure that the owner is willing to undertake is to replace all the windows. Currently they have single pane windows with wood frame, where they're original to the building and really not very efficient. So we go into the building envelope end use, where we defined our walls and windows and doors and roof. Under the windows proposed column, there are certain values that you can update. This is the U value that you see, and this is the solar heat gain coefficient. Now again, if you have the values from the spec sheet, you can straight up change the U values for all windows on the north, east, south, and west section. If you have different windows on different sections of the walls, if you have different windows on the north section, you can update the north value accordingly and the east value accordingly, and so on and so forth. For our case, I'm going to use the value that RETScreen recommends because we don't have the proposed values. So if you can just click on U value, there are two options. There are typical values for fixed windows, typical values for operable windows. In this case, it's a multifamily building with operable windows. I'm going to use the operable windows. I'm going to zoom in on it a little bit. The owner has decided to replace the existing windows with triple low E argon insulated vinyl windows. The value for which is 1.69, which is the total window U value, and the SHGC, or solar heat gain coefficient, is 0.46. So I'm simply going to change that in the proposed case for all orientations, because it's going to be the same window type throughout. And my solar heat gain coefficient was 0.46. And that is my window upgrade. And if you want to double check if you've entered or if you've changed the values or not, if you scroll down at the very bottom, you'll see it shows energy saving. So we know that we've changed the windows. There has been some savings through the building envelope upgrade. The next low-hanging fruit that the owner has identified is LED retrofits. We added, through a baseline model, we added all the lights, hallway lights, stairwell, CFLs, basement, unit lights, exterior lights. And if you click on lights in general, you can see how much energy there or electricity each of the different lights are consuming. And you can see the biggest or the most energy intensive are the unit lights. They are using the most amount of electricity, rightly so. So the owner decided or wished to upgrade all the unit lights. to LED. Now, in our model, we went ahead with a level 1 analysis, which is a watt per square feet or an LPD method, where you have the square footage of the area that's being served by these lights. You have a watt per square feet value, which is 1.5 in our base case. And we have the number of hours that the lights are on for those units. As per ASHRAE, and we're going to take ASHRAE values, as per ASHRAE 90.1, the most recent version, we know that for residential dwelling units, watt per square feet can go as low as 0.5 for residential units. So we are just going to change that, and we can see lighting electricity saved almost at 66.7%, which is typical when you go from fluorescent lighting or even incandescent to LED lighting. So these are all the upgrades that the owner has either decided to implement or already implemented. And if I go back to the comparison tab that Hardik was showing previously, now on the top right part of the screen, you'll see fuel saved. This is how much fuel we are going to save based on these 3 different retrofits / implement or upgrades that we're going to make. We are saving about 72,000 kilowatt hours and 6,700 therms. And our total energy savings is going to be almost 24%. This is what the model is predicting through the upgrade. What I do want to point out is if you go into include measure tab, there's a list of end uses and there's the check boxes on the right. If I check or if I check off all these boxes and I only click on building envelope upgrade or building envelope, it will give me the savings only from the window upgrade. So I can select a certain end use and thereby select a certain measure. So if it's a window upgrade and I only want to see savings from a window upgrade, I can check the building envelope end use from the include measure tab. Let's say I want to see the lighting savings only. I can click on, this was the line unit lights, and I have upgrade in parentheses to so that I understand where the changes have been made. And I can see that the savings, electricity savings are 66,658 kilowatt hours. But you also see some negative therm savings. Do any one of you know why there are negative therm savings or why the natural gas has increased? I mean, I'm asking in the room, but people in the chat can also answer. Yes, go ahead.
Yeah, so basically lighting lighting energy is converted into heat into the space. So now since we are converting into a more efficient lighting, so there's less heat that the lighting is contributing to the space. So that's why the HVAC system has to provide more heating to compensate for that.
Correct. Does that make sense? So your lighting, although you've saved electricity, but it's now not contributing to your heating as much, and that's why you see the thermic. Anyway, and what you're essentially describing is interactive effects, right? Certain measures interact with different measures, and if let's say you save 10 units of energy from window upgrade and 20 units of or 5 units of energy from a lighting upgrade, you cannot simply add both of them together to say that you will be saving 15 units of energy. There are interactive effects, and one measure affects the other, and maybe the cumulative sum could be 12 units of energy, but it's definitely going to be less. So to see how the interactive effects come into play for these measures, you need to check all the boxes and make sure that all measures are checked together. And now if I go back again, you'll see the total savings, and this accounts for your interactive effects. This accounts for how one measure is going to work with the rest of the 2 measures. Any questions so far? Okay, wonderful. Next, let's talk about costs. We've understood how much energy we are going to save. We also want to know what does the payback look like? What are my costs? Again, there are a couple of ways, or there are more than 2 ways actually, where you can enter costs in RETScreen. Let's start with the boiler upgrade. we've upgraded the boiler to condensing boiler. We know that it's efficient. If you know the costs directly, you can enter the cost in incremental initial costs. Let's say you have a contractor price, you can enter those costs directly. If you don't know, RETScreen also has a very large cost database, which helps you predict what the cost may look like for you. So if you click on the dollar sign, you can see that we've selected the boiler. There are 3 ranges: minimum, average, and maximum. Just to be conservative, I'm going to select the maximum. I don't want to overshoot the budget, but I want to make sure that I'm accounting for any issues that may come up later. So I want to be conservative. I'm selecting $904. And what does it include in the cost? Major equipment, major installation. What does it not include are the fuel connection, storage, and the flue vent. So that's something that you have to account for either in RETScreen or outside RETScreen. You can add that value within the software or outside, but it clearly shows you that what's included and what's not. And at the bottom, if you see, it also shows the exchange rate that Hardik was talking about. We've changed the units, and these numbers that you see are accounting for the exchange rate between Canada and the US. So I click on paste data and I see 904, but that doesn't seem right, does it? $904 for a condensing boiler. If you see on the left, it says USD per kilowatt. That's $904 per kilowatt of energy or of boiler capacity. Now again, there are 2 ways. I can select which boiler I have and it'll show me the kilowatt. But in this case, I know it's about a 300 kilowatt condensing boiler. So I can just type in 300 and it'll give me the total value. If I know the capacity of the boiler that I'm about to install, I can just type it in or use again the RETScreen database to pull up the manufacturer, the model, and you can use that capacity. So now it shows you that for a single condensing boiler, it's about $271,000. That's for your boiler upgrade. Let's go with windows. Again, if you have costs directly, you can enter the cost in this blue tab, and that's easy enough. But we want to use the RETScreen database. So let's see the cost database. Now we know that the client is replacing the windows with vinyl triple windows, triple pane windows. So I'm going to select vinyl triple in the drop down. You can select as many boxes here as you like, depending on what the specifications are. You have minimum, average, and maximum. Our window is operable type. It's not a fixed window. So I'm going to again be conservative, select the window cost, which is $384. I know it's a single low E, not double. So I'm only going to select 1. I know it's argon filled. I know it has an insulating edge space. And for installation, I'm also going to select the maximum value again to be conservative. If your window was a fixed type, you could select the values from the fixed type columns. And finally, you paste the data, and your total value of replacing the windows is about $400,000. Finally, we go on to our unit light updates. Similarly, I'm going to use the cost database. We have all sorts of different lights in the cost database. We know it's we know we are replacing it with LEDs. Again, selecting the maximum or being conservative, I select the initial cost for lamp, which is $45. I also want to select a high installation value just to be on the safer side. I select 36, and I know there are roughly about 200 lamps in the building, unit lamps within the building. So you need to specify the number of lamps, and I paste that data. I get $16,000 for the light replacement. Yes, go ahead.
What are the costs based on, or how often are they going to be renewed, for example? Because I mean, you have inflation, you have different things that affect the price, and how actual.
That's a good question. I don't know how frequently they update the cost database, but we have seen the numbers change. My guess would be every year or so. It's very typical of cost databases or construction databases to update every year, sometimes even quarterly. But that's a question that we can, get back to you on. We can reach out to RETScreen, ask how often do they update and what the source of these costs. Yes. go ahead.
Great follow-up question. What are we able to adjust the numbers manually?
Oh, the costs.
Yes.
Yes, you don't need to use the database. If you want to just adjust the numbers, let's say you want to add 20% to the 16,000 cost that you see, which is going to be roughly around a total of 20,000. So I can just manually change that to 20K. So the cost database is a reference point. If you want to use those costs, you can. But alternatively, you can also update the cost if you think you want to add certain costs that have been missed through the database. Like, for example, we saw in the boiler upgrade, the cost did not include fuel connection storage or flue vents. Now, and you do know the costs associated with those items, you can simply just add and it will show up in RETScreen. But that's something that you'll have to do manually. All right. Okay, so now I go back to my include measure, and there's no surprise. My lighting retrofit is going to give me the best payback. It's a low-hanging fruit, and we can see what the payback looks like. For boilers, it shows me a payback of about 40 years. Again, it's a long payback, but it's also typical of natural gas condensing boilers. Window replacement generally don't have any payback whatsoever. They're really expensive, but they do save a lot of energy. So you see 433 years, but it's virtually no payback. However, lighting, you see it's a 2.2-year payback. Also very typical of lighting retrofits. These are low-hanging fruits, and you can get your money back within a couple of years. Yes, you had a question.
Yep. What do we add for the incremental O&M savings?
That's a good question. So the question for people in the chat is, what do we enter in the incremental or O&M savings? For example, let me answer that with an example. You have a really old boiler. It's almost original to the building. It's 40 years old. And because it's so old, you're spending a lot of time and money towards the operation and maintenance of that boiler. When you replace it with a condensing boiler, the savings don't only come from your fuel savings or from the higher efficiency, it also comes from reduced maintenance, right? Let's say, again, I'm just going to spit out numbers. You're spending $20,000 every year on maintaining the old boiler. Now you'll be spending a lot less maintaining the new boiler, and that's what incremental O&M savings are. Yes. Wonderful. If there are no other questions, I want to go to the next part, and that's all for the measures. You can have multiple measures. You can see all the interactive savings. You can enter costs, and it'll spit out the total savings. It'll give you the total savings in terms of percentages. You can select a measure. So there's so many capabilities that you can do within RETScreen. Any questions, or should I go ahead with the next section? Yes.
How do we adjust the interactive effect? Like, for example, let's say if I change the lighting in a mechanical room where there is no heating and cooling, in that situation, but my model is still including that as a negative saving.
Correct. Great question.
Yeah.
The question is, how do I take out the interactive effects if I want to? For example, if there are lights in the mechanical room, or exterior lights, for example, that really do not affect my heating and cooling within the building. Mechanical room may or may not impact it, it depends, but exterior definitely won't impact your internal heating and cooling loads. So one, I strongly recommend that you separate out your end users as much as possible. So don't club your exterior lights with your in-unit lights or with your building lights. In this example, let me go to exterior lights. You see how I've created an exterior light section. In the bottom, if you see, my impact on space cooling and space heating is 0. Because I know these are exterior lights, I've turned down the ratio to 0% because I know it's not going to impact my space cooling and heating. So this is a very important part of the measures or of the end users. That's how you control your interactive. Does that answer your question? Yes. All right. So now we have predicted savings, and I want to stress on predictive because this is an energy model and we've predicted how much savings we're going to get out of these measures. The I know that the measures were roughly implemented in about 2023. I may or may not necessarily have the timeline of the measures. We are, let's say, in 25, we are in 25 now, and I want to see how much energy it actually saved. Can I do an MNV? The answer is yes. We can run a measurement and verification. We can run data analytics and see how much energy we've actually saved. It involves regression analysis, and I'm going to quickly show you how. So we've covered the location, facility, and energy tabs. I'm going to jump to the data tab on the top. In the data tab, going back to Hardeep's presentation, if you've synced it with Portfolio Manager, if you use ESPM Connect, it will sync data from Portfolio Manager to RETScreen, and you will see data in the data tab for all historical years and up to the most current data as until you sync it again, and it'll refresh the data. So this should be auto-populated if you've synced Energy Star Portfolio Manager to RETScreen. So in our model, we've already synced up. I've also gone ahead, and for the sake of this presentation and for simplicity, I've trimmed down all historical years. I've kept 22, 23, and 24. We know our 2022 is our baseline year. We know most measures were implemented in 23. And now we are in 25. We want to see what the savings look like. To do that, first, I need to understand what are the factors that affect my energy consumption. What are the factors that affect electricity and natural gas? The single most and the primary factor that will influence electricity and natural gas is going to be weather. So we need to add the weather data in to form a good baseline, right? So if on the top there's a button called weather, I click on weather, it automatically pulls the coordinates because we've established the facility, which is in Washington, DC. I hit next, download NASA data. Okay. And you can specify the time period. I want it to begin in 2022 and I want it to end in December 2024. I hit run or calculate. And in seconds, you will see your air temperature, averages, minimum, maximum, humidity, all the weather data. But I also want to see my heating degree days and cooling degree days. I want to compare natural gas with heating degree days and electricity with cooling degree days. There's an option called degree days on the top. I click on degree days. If I only want heating degree days, I can select that. If I want both CDD and HDD, I select that. I am going to assume my reference temperature or base temperature, as some call it, as 65 for the time being, and I just run. And if I go on the rightmost columns, you'll see the CDD and HDD populated from 2022 to 2024 onwards. From 22 to 2024. But I want to sync it with my electricity and natural gas. I want to merge the two data now. So what I can do is click on this merge function. RETScreen is pretty smart that way. It automatically selects a spreadsheet. So it selected electricity consumption. It somehow knows that I want to select the weather data, but I don't want air temperature. I want to compare electricity with cooling degree days. So I'm going to select cooling degree days because electricity is primarily being used for cooling in my building. And you see it's merged my data. Similarly for natural gas, I'm going to go hit on merge. Instead of air temperature average, I'm going to select heating degree days. Again, natural gas is primarily used for heating, and that's why we should see a good correlation between HDD and natural gas consumption. Now I have electricity, I have natural gas. What if I want to see both of the utilities combined, both of the fuel consumption combined? I can click on summary, consumption summary. You can see electricity consumption. I want the unit to be constant between the two units. Typically that's kilo BTUs or 1000 BTUs in RETScreen nomenclature. But I also want natural gas. So I click on this plus and it automatically gives me natural gas fuel consumption in therm. And it also has conversion factors, right? You can always edit the conversion factors if you want to, but for me, I think 3.41 to 1 and 100 therms per or 100 kilo BTU per therm is correct. So I'm going to keep it as is. And I'm just going to hit OK. There you go. So now I have my period, my duration, my electricity, natural gas in kilo-BTUs, and my total energy combined with my emissions. But I still want to see, now I want to compare the total consumption with weather. I cannot use heating degree days and cooling degree days both. I cannot just simply add them together, but I can compare it with air temperature. So again, the same, I'm going to merge the consumption summary. And there you go. I get the air temperature average for those particular months. This is just getting the data set ready for regression analysis. Now, question for you guys. We can either compare natural gas with heating degree days. We can compare electricity separately with cooling degree days and understand the electricity savings and natural gas savings separately. Or we can have a regression analysis for the total energy and compare it with air temperatures and get total savings. What would you like to say? You can say both. Yeah. Okay. Let's start with natural gas and electricity separately. Let's say we want to see how much natural gas we are saving, or we've saved, how much electricity we've saved. I go to the analytics tab. The first step is always to create a baseline. I want to establish a baseline. I want a regression curve. So I'm going to click on regression analysis. Again, RETScreen is smart enough. It knows that I'm going to create a regression equation with electricity with respect to cooling degree days. So it's already populated the dependent and independent variable, right? So I have cooling degree days, I have electricity. I just need to hit run. There you go. I have this regression equation, and again, I'm not going to get very detailed with what the numbers look like, what the details is, but all I want you to see is that it's created a correlation between electricity and cooling degree days, and there are certain periods or certain consumptions that are up and down of this line. It just shows that the correlation is not that great for those points. The next step is to have a cumulative sum. Instead of, actually, let me back up. What we're doing is we are trying to use a baseline to predict what the consumption in 2024 should look like, and then comparing with the actual data that we have from Portfolio Manager. And the difference will either be energy saved or energy increased, right? That's what we are trying to plot. A regression analysis will help us with that. It will help us predict based on 2022 what the consumption in 24 should look like. So I'm going to click on cumulative sum, and you see this is, instead of comparing every month and every curve, I want to sort of have a moving or a running total of the difference. So if in month one, I have actually used more or used less than what I predicted, it's going to be negative. And if I see this chart going up, it just means that I'm not saving energy. The moment it starts going down is when I'm starting to save energy. That's what essentially this chart is showing you. So you see, I go up till March of 2023 and it starts going down. So I have a certain idea that that's when a certain retrofit may have happened, and that's when I start seeing savings. There's another dip somewhere around here, and it keeps going down. So I know that something happened in 2023, and it kept going down. This is your overall regression analysis. This is only to understand where I need to stop my baseline at. So I'm going to create another baseline. Again, the same, 65. Now, in the baseline, select baseline column, I am going to end the baseline in 15 months. Because if you remember, in March 2023 is when the graph started going down. And I can go back to show you. So March 2023 is when the chart started going down, which means I'm saving energy starting from those points. And there are 15 months leading up to March 2023. So I changed the baseline to 15 months, and if you studied regression, you would know that R square of 0.982, it's a very strong correlation. It's a very nice regression equation, which means it's 98.2% efficient. So now we have the baseline. I'm going to run the same cumulative sum. And you can see how the graph falls down after that point. This again just means that I've started saving energy from that point onwards. Now I go back to, let's say, the building engineer. I ask what really happened in March 2023. He tells me that, oh, we did the lighting retrofit. We replaced all the lights in the first 3 months of 2023. And that's probably why you see this chart going down. But I still don't see how much energy I've actually saved. What I need to do is click on measurement and verification. You see the green line? The green line is your actual energy. The blue is what the model predicted based on the weather data, based on a regression equation. The blue line is what the building should have used. The green line is what is actually used starting from that period onwards. I can also fill it. I know the commission date is 31st March because that's when my LED retrofit was completed. And I want to calculate savings only for 12 months. I want annual savings. So I want savings starting 1st April, going all the way to, let's say, again, March 31st, 2024. 70,578 kilowatt hours. That's my actual savings. Let's go back. Let's see how it compares with our predicted model. I want to go back. I want to go to lights, or I want to go to include measure, uncheck all the boxes. If you remember, if I want to see only a particular measure, I select that end use, which is unit lights in this case, go to comparison and shows 66,658. So hooray, we saved more than what we predicted, which is 70,578 kilowatt hours. That's your MNV for lighting. Why do I stop here? Because out of the 3 measures that I implemented, lighting was one of the only measures that would save a lot of electricity. The rest, the remaining 2 measures, window replacement and even the boiler upgrade, most likely affects the winter season, most likely affects your natural gas consumption. Window upgrade does give you some electricity savings, but this building does not use a lot of, it's not very cooling dominated. And I can go back and show you why that's true. So if I go back to energy, let me select all the measures again. I go to comparison and you see this end use, this pie chart. This shows me what the end use consumption looks like. You see 60% of the energy is towards space heating. My cooling, only 9%. It's less than 10%. So my window upgrade, although it will save some electricity, it will save some cooling energy. It's not going to be significant. My savings most likely is going to come from space heating. And hence, sorry. I stopped at Does that make sense? Do we want to do natural gas? Let's again the same idea. I want to create an overall regression for natural gas. So instead of electricity, I select natural gas. It auto populates heating degree days. Again, smart enough to select heating degree days as an independent variable. I hit run. This is my regression equation for natural gas. What I'm essentially doing is creating a baseline. Click on cumulative sum to see when the energy start going down. So this is 22. It increases in 23. There's no energy saved. There's a little bit of drop here in 23, but the biggest drop comes after December 2023. That means that there's something happened by the end of this year which has reduced my natural gas. I go back to my building engineer, again ask him, what's up, what's happening with the data? What did you do by end of this year or by end of 2023? And they rightly so, they did the window replacement, they replaced all the windows, they upgraded the boiler. It took a lot more time than a lighting retrofit because it's more intensive, there's a lot more work involved, and it was completed by end of 2023. And hence I see the cumulative sum going down. Hence I see the energy going down after 2023. Again, what I need to do is create a regression analysis. Now I know my baseline. I run the analysis again, but instead of 3 years, I change my baseline to 24 months, which is the whole of 2022 and whole of 2023, because my savings will start from 2024 onwards. My values changed. I do cumulative sum, and again, you see how it drops immediately after 2023. What do? You click on measurement and verification. Now I want to know how much thumbs I've saved. 5,220. This is with both window replacement and boiler upgrade, which ended almost simultaneously by end of 2023. I want a whole calendar year. By default, it has a calendar year data, which is, or I want an annual year. It has 2024 and the savings end in December 2024. I can fill it by color, and I have 5,222 thumbs. Let's check how we did on our energy modeling part. We estimated 6,700 thumbs. So we overestimated our savings during our energy modeling exercise. We can go back, understand what we may have overestimated if we need to, sort of tweak something. And that will help us get back to the actual number. But this helps us understand that we were not very far off, but we still overestimated our natural gas. And we, at the end of the day, ended up saving 5,222 pounds. So that's our natural gas savings. This is our electricity savings. Similarly, we can plot the similar graph for the total consumption versus air temperature. What we did was run regression and MNV for individual fuels. We can run it as a property, and I can quickly show you that too. Again, same procedure, regression, but this time I don't want electricity consumption, I don't want natural gas, I want consumption summary, and I want the total energy. That's my dependent variable. My independent variable is going to be air temperature average. That's what I'm comparing it with. That's what's affecting my total consumption. There you go. I have a graph. Again, I do a cumulative sum. And at this point, I already know that all the measures were completed by end of 2023. So I don't need to go by March or December. I don't need to separate my savings. I can just directly establish a new baseline. Total energy, compare it with air temperature average. I change my baseline to 24 months, which is 22 and 2023, do my cumulative sum. And clearly the energy starts going down. Measurement and verification. 643,000 kBtus. Let's compare how we did on our energy modeling. This is the portion where you see the savings. I want to see it in 1000 BTUs. I predicted 919,000 kBtus of energy saved annually. Again, overestimated, and it's probably coming from the natural gas overestimation. But actually, we ended up saving about 643,000 kBtus. That's your actual real savings. I know I've thrown a lot of information at you, and I think we have time. We have some time.
Are there any questions?
Are there any questions? Yes.
Yeah, in the chat there is one question. Is this software tested in reference to ASHRAE 140, and is it utilizing Energy Plus engine?
No and yes. And correct me if I'm wrong, Hardik. It does not follow the ASHRAE guidelines. However, I do want to point out that it is accepted by a lot of jurisdictions. If you're doing an energy audit, or if your project requires an energy modeling, it is, but you'll have to sort of talk to your jurisdiction or to your department to see if this software is accepted. And yes, it accepts Energy Plus.
I can chime in. It's not based on energy plus. It's using its own monthly based calculation, and therefore this is not hourly. It's not actually standard 140 compliant. Yes, it cannot be used for federal tax incentive modeling, code compliance modeling, or lead modeling. It's not 140 compliant. That doesn't mean it's not valid, third-party validated government software, which is highly useful for identifying, implementing, and validating energy efficiency measures.
Should I repeat that or?
Yeah.
So it's not utilizing Energy Plus. You probably cannot. It has its own backend software. It has its own database, and you probably can't use it for federal tax incentives or any tax incentives.
It doesn't do hardly
Thank you. It does not do hourly simulations either. Anything else?
No, it's highly useful for
It is right. Yeah.
identifying measures that they can validate.
Yeah. Are there any more questions?
Yes, there is one more related to.
Yes. Do you want to take it? Yeah.
So there was one question in the chat related to benchmarking, whether we can do benchmarking using total carbon emission. So the way you do it is you go into the facility. So over here, the thing that we discussed during this case study was based on fuel consumption. If you go down, there is an option where you can benchmark the property based on carbon emission as well. So there are, for BEPS compliance, like there are few jurisdictions that require you to meet the emission requirement. So this is a place where you can see whether your property is compliant with emissions target or not. So you need to have the benchmarking. That is something that you get from jurisdiction. For the base case, depending upon the total energy usage, you can estimate the carbon emission and plot a graph to understand whether you are meeting that requirement. Just an example, like suppose if right now you are at 35 and this requires 50 and you have a, so you can just understand from the emissions perspective whether it is complying with BEPS.
Question. Are there any BEPS standards that require both emissions targets and energy targets?
Yes. So,
Can I take that? So the state of Maryland right now has direct emission standards, but they are also very confident that they're going to roll out energy use standards or site EUI standards very soon. So state of Maryland will be one of the few jurisdictions that will have both site EUI and direct emission standards.
yeah, even Colorado is.
Thank you.
And just one other question. What kind of fines are we talking about that you pay for BEPS non-compliant?
Great question. So the question again for the chat was, what kind of fines are we talking about for these jurisdictions that have building performance standards? It depends. It depends on the jurisdiction. I can give you a few examples. In DC, your BEPS standards is Energy Star score based, meaning if your performance is below a certain Energy Star score for your property type, you are put in a compliance cycle. Again, for example, multifamily buildings, they need to be at a score of 66 or above to not be in the compliance cycle. If they're below the compliance cycle, you have 5 to 6 years to save energy. If not, you're penalized, and the penalties are flat $10 per square feet. So that's a per square feet based penalty in DC. It's a one-time penalty for that particular compliance cycle. Then you have a second compliance cycle that runs again for 5 years, and they'll probably revise the penalties. We don't know, but right now it's a per square feet penalty in DC. Of course, it's prorated based on how much you've saved. If your requirement was saving 20% and you ended up saving 10%, your penalties are cut in half, so on and so forth. For other jurisdictions like Montgomery County and the state of Maryland, for state of Maryland, your penalties are, or as they're calling it, alternative compliance payments. They are based on the metric ton of emissions. So it's not per square feet. It's per metric ton of CO2 difference between the target and how much you're emitting. So let's say you're emitting 2 kilograms of CO2 per square feet, and the standard requires 1.5. So you'll be penalized for the difference, which is 0.5. And they have certain penalties. I think for Maryland, it starts with $230 per So you also need to sort of convert the units and see what it looks like. But this is not a one-time fee. This is annual and it stops until you meet the standard. So for example, the penalty start in 2020, 2030, and you were below the standards, you're not meeting the direct emission standard, you face a penalty, you pay the penalty, you go in 2031 and you're still not meeting the standards, you again pay the penalty based on the difference between your consumption and the standard. It stops as soon as you meet that standard. Yes.
Follow-up question. You guys talked about changing windows that had a 448-year payback, right? Well, I'm not gonna live that long. Why don't I just pay the fine? Right? How can I tell? How can I leverage RETScreen to make sure that it's not just cheaper to pay the fine than to buy windows and boilers that have 80, 400-year paybacks? How can we use RETScreen?
So the question again for the chat is, the payback for Windows in this example, in our example, was the payback was 440 years, which is enormous, and we have, to your point, we're probably not going to stay long enough to see that payback. Can't I just pay the fine instead of replacing my Windows? And how does RETScreen come into play? How can RETScreen help me here? One, it does not just reduce your penalties, it also saves you energy. So you're reducing your energy consumption, you're increasing your thermal comfort while saving your energy. So your payback, although it looks 430, it looks like it's 433 years, but that does not account for your saved penalty, right? So if you account for your saved penalties, let's say you're facing $1 million penalty, and by replacing the windows, you've met your standards, you've met your requirements. That's not a 433-year payback, that's an immediate payback, because you've invested $400,000 to save $1 million in penalty. That's how we should be looking at with such extensive measure. Any questions on the chat? I think. Any questions from the people in the room? Yes.
Are they exclusively when they calculate the penalties, what sorts of space do they consider? Is it like every square foot on the floor? Is it like lived space?
So the question, if I understand correctly, when they're calculating penalties, how do they measure the square footage? What do they consider in terms of square footage? Is your gross floor area? What is gross floor area in this conversation? That's a good question. And let's talk about DC, because this is a DC compliance requirement, right? It's $10 per square feet. DC has very strict guidelines on how they define gross floor area. For example, balconies, they're not gross floor areas. EPA actually also has that. Can you, while I answer that question, can you pull up EPA's definition of? So Energy Star Portfolio Manager also has a definition of what gross floor area is. It does not include balconies, it does not include crawl spaces, it does not include any exterior spaces. You want to look at it as a space that has basically on the four walls, your floor and a roof. An atrium is tricky, right? Your atrium, although it extends up to 4 floors, you're not using every floor to measure your area. It's only where you have a floor and a roof. So there. One second, let me pull that up quickly. You might. Now there's a certain sorry. And that's a great question. And we've had so many clients ask that or report incorrect area because because they wouldn't know what to include in the gross floor area, and that impacts your metrics and hence your compliance. And this becomes a very large conversation, at least in DC.
And it is a place where energy benchmarking verification comes. So most of the time, the benchmarking that is usually done is done by property managers who are not having a technical background. So all the data that is entered by the owners usually tend to get verified by consultants to ensure the gross floor area or the utility bills that they are uploading is correct. Once you have that information corrected, then it is recommended to see whether it is compliant.
Are we also sharing the screen with the attendees?
Yes.
Okay, so that's what you include in your gross floor area and that's what you exclude. We can also send a link in the chat if you want, or after this call, we can send that over to you, but it's very important to note what's included, and that's how the Department of Energy or whoever the guiding body is would want you to measure the area.
Okay, so these are conditioned spaces.
Yes, these are conditions.
So there are two questions. For a project that is part of full campus build, does RETScreen have the ability to use submetering data for calibration and MN?
Yes, it does. It depends if you're using the portfolio analysis tool in RETScreen using the ESPM Connect. If you have these meters very well classified in Portfolio Manager, you can assign those meters accordingly. You can actually have a meter chart. There's a meter chart in RETScreen. We did not show that to you for this training, but yeah, Arthik is pulling that up. Short answer, yes, you can have a sub-meter level analysis and also use that for your MNP. It's
Just a clarification for people, often on campuses, people talk about submeters being at the building level. It sounds like you're talking about submeters at the end use level.
yes, I'm talking about the sub-metering at the end use level, not at the building level.
And they're asking about it.
Sorry, what's that?
They may be asking at the building level.
Yeah, okay, you're asking, if you're asking for a building level, I think you can still do that.
Yes.
Yeah, so
Yeah,
we should
you-
be able to import the submetering data into RETScreen, and using MNV, we should be able to.
Yeah. Also, separately, you can also upload data to REDScreen. You can use ESPM Connect, but let's say you have submetered data for the building level in a spreadsheet. You can upload that spreadsheet in REDScreen and do the same analysis as we showed on a building level. So if you want to look at the building level and not the campus level, you can do that too. And it doesn't matter if you have the data in ESPM or not. You can just upload those spreadsheets also.
The last question is, can be used for lead applications, or is it free or no?
It can be used for the integrated process.
Yeah, so it can be used for lead integration process, and software is not free. I mean, the trial version is free, but if you want to use like all the features of RETScreen, there's a monthly subscription that needs to be, annual subscription that needs to be paid for that. And I think once you have the subscription, there are up to like 12 users who could potentially use the software together.
There's a question in the chat. Actually, a couple of questions. Did we answer that already?
Yes, I think, yeah, everything.
Okay. The last question was, can you share the recording? We're going to.
Yeah, IBPSA has recorded the training, so.
And it's going to be in their on their website. So yes, you can get that recording.
Just a reminder again, for attendees who have attended this training, you are eligible to get 3 credit from GBCI that you can self-report on USGBC website. Apart from that, you are also eligible to get a 30-day free trial for using RETScreen. So we will be sending out the link to download the software for everyone who has registered for this webinar. Thanks everyone for attending.
Thank you so much. Apologize for the technical glitch, but I hope you had a good time. Let us know. Feel free to reach out outside this webinar. Happy to answer any questions that you may have. Yeah. Have a good one. Thank you.